Right. So therefore now, method number 2, let's go to the list of formulas to calculate the variance and standard deviation of a data set. That's a measure of dispersion. We go to the list of formulas. In the list of formulas, we have, here's the formula for variance and standard deviation for a set of raw values using method number 2. So let's take a snapshot of it. And as we know, the standard deviation is the square root of the variance. Here's method number 2. When you look at the formula, the variance is equal to the sum. So here's sigma again. The sum of what? The sum of x squared. So ignore sigma, we have to do x squared. We know the mean to be 78.83. Okay. The mean is 78.83. There it is. Here's the mean, 78.83. Yeah, we use it here. We use it here for method number 1. We're going to use it for method number 2 now. So therefore now, and the n now is 12. Okay. So what we have to get now is the sum of x squared. But we have to get x squared first before we sum. If you look into your assignment, the head start is already given to you. Method number 2, we have to find x squared first. Okay, so we have to square 61, you have to square 94, you have to square 96. So you'll go in your calculator and you type 61 squared $3,721. So you type 3721 there, and you will go, you know, gently poko till when you do all 12 values. Imagine you have 3,200 values. So therefore now you go to Excel. The values are there already. Here they are. Let's delete this. You can leave the sum there still because the sum will be needing the sum. So you can leave that there still. What we want is x squared. Okay. X squared equal a2 squared. All right. A2 raised to the power of 2. Enter. Okay. You see it, a2 squared. 57 times 57. You want to verify? 57 times 57. Enter. 3249. 3249. Go to the little green square, double click, bam, and it give you the sum one time, centralize. And then you just copy this, Control C, go back to your assignment. You can delete this, or if you want, you can paste it inside itself, because you can paste from Excel into a table. So you can paste it inside that table itself. So you really have to delete the table. You can paste it inside of it. Okay, but you don't need that extra column. Okay, so I can just delete the whole thing and just Control V into your working. And here we go, Control V. Okay, so we have gotten this number up there, the sum of x squared. First we form the x squareds and then we find their sum. Now we're going to continue with the formula. Now the formula says we have to divide that by n. Okay, so therefore now what I need to work in that blank space there, but the table from Excel preventing me from typing there. So what I need to do now is to paste in it. All right. Right. Now bear in mind we are doing method number 2. So S squared is equal to, let's go to the formula, the sum of X squared divided by N, 77676. So compare this method with method number 2. Okay. Subtract the mean square, the mean is 78.83, 78.83 all squared. Highlight, go to equations, superscript, square. Oh, let me see if we get 258.31. Highlight, copy, go to the formula, paste, delete this. Make sure you use brackets when you're doing this, and then press enter. Right. So if you are doing this, you can, one time in your calculator, you can put this fraction there in brackets. Put that fraction in brackets, 776 divided by 12 in bracket minus the mean in bracket squared. Okay, and see whatever you got. I got 258.831, 258.831, same values. Not all times you'll get the same value for the variance for different methods. But because we did not really round off for the first method, the second method gives us the same answer. Actually, the second method is a little bit more accurate because it's using the mean less. So we are rounding off less. So therefore now, normally they call the second method a shortcut method. Okay, but any method you do, once you get the correct answer is all. So coincidentally, we get the same value for the variance, square root the variance to do the standard deviation. And we got the standard average value, the average spread, or difference between the scores is 16.07%. Standard deviation for raw data using method number 2.